This is a video about arcs and sectors of circles. An arc is the part of the circumference, the curved length of this line around this part of the circle, and a sector is a part of the area. Before we start, you have to be quite clear about the formulas for circumference and area. So hopefully you remember that circumference is 2 pi r and area is pi r squared. That those are the formulas for the circumference of the whole circle and the area of the whole circle. So suppose that I wanted a quarter of a circle. Well, the whole of this topic depends upon getting your head around that it's the same fraction of the circle you're dealing with, regardless of whether you're dealing with the angle. So if I wanted a quarter of a circle, I would have a quarter of the 360 degrees that's in the middle here. So this would be 90 degrees. If I was dealing with a quarter of a circle, the arc would be a quarter of the circumference. And if I was dealing with a quarter of a circle, the area of the sector would be a quarter of the whole circle's area. So regardless of whether I'm dealing with the angle, I've got a quarter of the angle for the whole circle. The arc is a quarter of the circumference for the whole circle. The area is a quarter of the area for the whole circle. It's the same fraction regardless of whether I'm measuring it by angle, arc, or area. So what would happen if I changed it to go for 1/6? I know it seems obvious, but I'm building up to something here. So the arc here would be 1/6 of the whole 360 degrees. The arc length here would be 1/6 of the whole circumference. So the length of this bit of the circumference is 1/6 of the whole circumference. And the area of this bit of the circle, the sector, would be 1/6 of the area of the whole circle. Again, same fraction of the circle. What about if I'm dealing with a 120 degree sector? So this time I've changed it slightly. Instead of telling you the fraction of the circle that I want, like 1/4 or 1/6, I'm telling you the number of degrees. But I'm still dealing with the same thing. I've got to work out what fraction of the circle this is. Okay? So it is 120 out of 360 degrees of the circle. So it's 1/3 of the circle, which means that the length of this arc will be 1/3 of the circumference, and the area of this sector will be 1/3 of pi r squared. So once I've figured out the fraction of the circle I'm dealing with, I apply that fraction to the other ways of measuring, whether it's arc or area or degrees. What about if I'm dealing with an unpleasant number? 217 doesn't cancel as easily as 120 did, but the principle is the same. I've got 217 out of 360 degrees. So I've got 217 360ths of the circle. That's my fraction. Therefore, the length of this arc will be 217 360ths of the whole circumference. And the area of this sector will be 217 360ths of the whole area. So whatever fraction of the circle I'm dealing with, I apply that to the arc, the area, or the angle. So to summarize that, in your course notes here, got a little reminder of the terminology: radius, sector, arc, and the various formulae. Area is pi r squared, circumference is 2 pi r, or sometimes written as pi d. If I wanted the length of this arc, or the fraction of the circle that I've got is 40 degrees out of 360 degrees. So I would have that fraction of the whole circumference. So 40/360ths of 2 pi r. And the area would be that fraction of the whole area. So 40/360ths of pi r squared. Now what about if the initial information they're giving me is not about the angle, but about, let's say, the arc length? Well, the structure of the question is exactly the same. I've got to find the fraction of the circle that I'm dealing with. They've told me that the radius is 5, so I can work out that the circumference of the whole circle, 2 pi r, would be 31.4. I've got this bit of it, so I've got 10 centimetres out of 31.4 centimetres. So I'm dealing with 10 31.4ths of the whole circle. That's my fraction. Now I've figured that out, it's easy to apply it. The angle at the centre here must be 10 31.4ths of the full 360. And the area of this sector here must be 10 31.4ths of the area of the whole circle, pi r squared.